Shannon MATHCHICK Myers, and today we are looking at an example from the Larson and Edwards text from 12.4, number 25, and this is for my Calculus 3 class. All right, let's get to it. So we need to find the tangential, I can't talk today, tangential and normal components of acceleration at the time t equals 2 for our plane curve r at t, which is equal to t times I plus 5 over t times j. So let's just take a look at what we've got. X at t is just equal to t, and then y at t is equal to 5 over t, which equals 5 times t to the negative 1. And if we take a look at what we need to find here, so at the end of the day, we need, that is the tangential component of acceleration, and that is found by finding a dot t. We also are going to need to find the normal component of acceleration, and that is found by finding a dot n. Now, t is found by finding r prime at t over the magnitude of r prime at t. So, let's go for it. So, r prime at time t is equal to the vector 1, comma, negative 5 over t squared. Cool so far? And then the magnitude of r prime at t is equal to the square root of 1 squared plus negative 5 over t squared, the quantity squared, and that is equal to the square root of 1 plus 25 over t to the 4th, which is, getting a common denominator, t to the 4th plus 25 over t to the 4th, which will give us the square root of t to the 4th plus 25 over t squared. Good so far? Okay, so putting this together to find t, we will have t is equal to r prime at t over the magnitude of r prime at t, which in turn was equal to the vector 1, comma, negative 5 over t squared over the square root of t to the 4th plus 25 over t squared. So, we got this result from here. We got this result from here. So bringing it all together, t will be equal to, if we invert and multiply, we will have t squared over the square root of t to the fourth plus 25, comma, negative 5 over the square root of t to the fourth plus 25, the t squared in the denominator flipped up to become a multiplier. Groovy? Okay, we're almost there. Now we need to find a few more things. So we need t in order to find n. Okay, so this is, if we want, we can say, I'll make a little space here. And so this will be t at t. Okay. And then to find t at 0, or not 0, I'm sorry, t at 2, we just plug in 2's wherever there's a t. So we'll get 2 squared over the square root of 2 to the fourth plus 25, and then negative 5 over the square root of 2 to the fourth plus 25. And so t at 2 will be equal to 2 to the fourth is what? 16. 16 plus 25 is 41. So we'll get 4 over root 41, and then negative 5 over root 41. Cool, cool? And that's t at 2. So to find the normal component, we had that our t at t was equal to, I'm going to just write it as, I can write it in the vector notation. We have t squared over root t to the fourth plus 25, comma, negative 5 over the square root of t to the fourth plus 25. And that is a vector. So t prime at t will be equal to, so the first component, we'll have 2t times the square root of t to the fourth plus 25 minus t squared, using the quotient rule, times 1/2. The chain rule gives us 4t cubed in the numerator, and then we're going to have t to the fourth plus 25 to the negative 1/2, which looks like this in radical notation, all over the denominator squared is t to the fourth plus 25. On the other side, we'll have, we basically have negative 5 times the quantity t to the fourth plus 25 to the negative 1/2. So negative 5 times negative 1/2 is positive 5/2 times t to the fourth plus 25 to the negative 3/2 times 4t cubed, using the chain rule. And now simplifying, finding a common denominator for the numerator, we're going to have root t to the fourth plus 25. So we need to compensate by multiplying in the numerator by root t to the fourth plus 25. So that will give us 2t times the quantity t to the fourth plus 25 minus, this 2 divides out some of the 4, so we'll have minus 2t to the fifth, and that's all over the square root of t to the fourth plus 25 times quantity t to the fourth plus 25 to the 1. For the next component, the 2 divides out some of the 4, and so then we'll get 10t cubed over t to the fourth plus 25 to the 3/2. Continuing to simplify the first component, we'll have this here will give us 2t to the fifth plus 50t. So those 2t to the fifths zero out. So we'll just have 50t over quantity t to the fourth plus 25 to the 3/2 when I multiply out that denominator, and then 10t cubed over t to the fourth plus 25 to the 3/2. Good so far? All right, excellent. Now, here we go. This will give us our next step, which is the magnitude of t prime at t. And that will be the square root of 50t over t to the fourth plus 25 to the 3/2, that quantity squared, plus 10t cubed over t to the fourth plus 25 to the 3/2, this quantity squared, and that will be the square root of 100t squared, nope, making up my own math, 2500 t squared. They're both going to have the same denominator, so we'll have plus 100 t to the 6 over t to the fourth plus 25 cubed. So I can factor out from the numerator 100t squared. I'll be left with 25 plus t to the fourth, and look at that, that's what we have in that denominator. So this divides out one of these. So we'll end up with 10t over t to the fourth plus 25 for our magnitude. Now putting it together for n. So n at t is t prime at t, which we found to be 50t over t to the fourth plus 25 to the 3/2. The other one was 10t cubed over t to the fourth plus 25 to the 3/2. And we'll be dividing that by 10t over t to the fourth plus 25. So that will clean up to be, I'm going to invert and multiply. So 50t divided by 10t is 5. And then we'll end up with just the square root of t to the fourth plus 25. For the next one, we'll end up with t squared over the square root of t to the fourth plus 25. And n at t is, n at 2 is 5 over 2 to the fourth is 16, so I'll have root 41. And then we'll have 2 squared is 4 over root 41. Cool, cool? And so, the acceleration, the component of acceleration, the tangential component of acceleration is going to be equal to a at 2 dot t at 2. Remember that r prime at t we found earlier was 1, and then what was it, negative 5 over t squared? Yep. And so a at t will be the second derivative, so that'll be 0. And then we'll have a positive 10 over t cubed. And so a at 2 will be 0, 10/8, which is 5/4. So we will have 0, 5/4, dot, and t, remember at 2 is over here, 4 over root 41, and negative 5 over root 41, and that will be 0 minus 25 over 4. So we'll get negative 25 over 4 root 41. And then the normal component of acceleration is a at 2 dot n at 2, and that will equal to 0, 5/4, dot, we just found n at 2, so the first part will 0 out, and we'll get 5 over root 41. All right, so lots of algebra in that one. Anyway, hope this helps, and I hope we're having a wonderful morning, afternoon, or evening whenever you're watching this show. If you like what I'm doing, go ahead and hit that subscribe button, like the video, and share the video if you'd like. Bye. See you soon.